EC2 Fundamentals Auto-Scaling. In the previous video, we discussed about load balancing. When we deploy multiple EC2 instances on multiple availability zones and distribute traffic between them using a load balancer, the availability of the application is improved to some level. But what will happen if all the instances goes down? Then the application becomes unavailable. To avoid that issue, there has to be a health check system that periodically monitors the health of the instances and replace the unhealthy instances with healthy instances. Another issue of this load balance only architecture is that it can become unavailable if the application receives a spike in demand. To fix this issue, there has to be an auto-scaling system that scales the system out and in based on the application's demand. An announcement: I wrote a LinkedIn article on load balancing and auto-scaling, which has this information in detail. I can guarantee that it will be helpful, so don't forget to read it. I will leave a link to it in the description. Now let's improve the architecture by adding auto-scaling. Similar to the previous architecture, the architecture above shows that multiple EC2 instances are deployed on multiple availability zones, and a load balancer is used to distribute traffic between them. Additionally, the target group is now associated with an auto-scaling group. Now let's talk about the benefits of auto-scaling in detail. Fault tolerance, high availability, and cost management are the benefits of auto-scaling. Auto-scaling groups can perform periodic health checks and replace any unhealthy instances with healthy instances. These health checks provide fault tolerance to the system. Additionally, auto-scaling groups can automatically scale out or in the number of instances to match the demand. Scaling out can provide high availability for the application because the application will always have a sufficient number of instances to support the demand. Scaling in can provide cost management because that removes additional instances when the demand is low. Now we know the benefits of auto-scaling. We'll look into how to configure auto-scaling for EC2 instances. In this video also, we'll be using the same Node.js application that we used in our previous videos. This is a simple Node.js server that prints hello world. In the description, I will leave the link to the GitHub project of this code. Before start configuring on AWS, I recommend to draw a configuration diagram. Without a configuration diagram, it can be confusing where to start and what order to proceed. We should start configuring components which are not dependent on the other components. After completing the configurations of the independent components, we can start configuring the dependent components. So we can start configuring the security groups because they are independent. Let's start with the EC2 security group. The EC2 security group should allow HTTP traffic on port 8080 from the load balancer security group. Why port 8080? That's because our Node.js app is listening on port 8080. Why only allow traffic from the load balancer security group? That is because there is no reason for the EC2 instances to receive traffic from any other source. For this project, you can also allow traffic from any source, as in the screenshot. If you want to connect to an instance via SSH, you can also allow incoming SSH traffic as well. Add an outbound rule to allow all traffic to any destination. Next, we can configure the load balancer security group. The load balancer security group should allow incoming HTTP traffic on port 80 from any source because the load balancer is internet facing. Add an outbound rule to allow all outgoing traffic to any source. Next, we can configure the launch template. The purpose of the launch template is to tell the auto-scaling group what configurations should be used when launching an EC2 instance. In a launch template, we mainly define the security group and the OS image. The security group is going to be the previously created EC2 security group. Select Amazon Linux 2 as the OS image. In the launch template, we can define EC2 user data, which is a script that runs when an EC2 instance is launched. In this project, we want to add EC2 user data. This is the user data script. It does the following tasks: installing Node, installing Git, cloning the project from GitHub, and running the Node server. Notice that the auto-scaling group is dependent on both the target group and the launch template. The target group is not yet created, so we still cannot configure the auto-scaling group. Next, we can go ahead and create a target group. In the target group, the protocol is HTTP and port is 8080. Again, these are dependent on our server running on the EC2 instance. We don't want to register any targets to the target group because targets are going to be registered by the auto-scaling group. Next, we can create the load balancer. The load balancer type is application load balancer. The scheme is internet facing. Define at least 2 availability zones. When defining the auto-scaling group, make sure to define the same availability zones. In the routing section, we want to route the HTTP traffic on port 80 to the previously created target group. Let's take a look at the configuration diagram again. We have already created the launch template and the target group. Finally, we can now create the auto-scaling group. Associate the previously created target group and the launch template to the auto-scaling group. Define the availability zones on which the EC2 instances should be launched. Make sure that they are the same availability zones defined on the load balancer. Enable health check to add fault tolerance to the system. Define the desired capacity. The desired capacity is the number of instances in the auto-scaling group at a given time. By default, an auto-scaling group doesn't have auto-scaling enabled. It is a little confusing, but you can think that it is just a scaling group by default. In this case, we can manually update the desired capacity to scale the number of instances. But in this project, we are enabling auto-scaling. So regardless the desired capacity that we enter, the auto-scaling group will update the desired capacity based on the workload. Define the minimum capacity. This is the minimum number of EC2 instances that the auto-scaling group can have. Define the maximum capacity. This is the maximum number of EC2 instances that the auto-scaling group can have. Enable auto-scaling with target tracking scaling policy. With target tracking scaling policy, you can scale the system based on a metric like CPU utilization. We have reached the end of our course on EC2 load balancing and auto-scaling. For auto-scaling, I have written a LinkedIn article which contains detailed information such as how to test auto-scaling. So don't forget to read that article as well. I will leave a link to it in the description. At the end of the project, make sure to delete the AWS resources that you created so that you will not get additional charges.